For an ideal measure of central tendency. So whenever we are considering that measure of central tendency, that should be ideal. So what is criteria for that ideal measure of central tendency? So the first is it should be properly and unambiguously defined. So whenever you are considering any variable, that should be properly and unambiguously, means there should not be any biased. Okay. Second is it should be easy to comprehend. So whenever we are handling that problem, it should be easy to comprehend. Third is it should be simple to compute. Yes, this is important. So whenever we are finding that measure of central tendency, so calculation should be simple. Fourth is it should be based on all observations. So each and every observation is important for finding measure of central tendency. The fifth one is it should have certain desirable mathematical properties. Yes, this is also there. Whenever we are considering any calculation, that mathematical properties, it should be satisfied by that data. And last is it should be least affected by the presence of extreme observations. So if I am finding any measure of central tendency, so it should be least affected by presence of extreme observation. So if any extreme observation is there, it should not affect on your data. So these are the prerequisite to find measure of central tendency. Okay. So the first one is arithmetic mean. Before start with this arithmetic mean, I want to tell you there are different types of data. Now what those types of data? First is individual observations. So let us consider you have data something like x1, x2, x3, x4 dash 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 xn. So these are what? These are individual observations. Now this is the first one, individual observations. Now second is this individual observations also called as ungrouped data. Alright. The second one is group data. Now in this group data we have two types of data. One in terms of individual observations with class frequencies, and another is class intervals and class frequencies. For example, suppose I have my observations as x1, x2, x3 dash 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 xn, and corresponding frequencies are f1, f2, f3 dash 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 fn. So this is called as what? This is called as group data, but individual observations we have frequencies. Okay. Now the next is what? The frequencies in terms of class intervals. So in this case they will give you class intervals and corresponding frequencies. For example, class interval is 0 to 10. So its corresponding frequency, let us consider it as 10. Okay. From 10 to 20, it will be 20. So like this we will have this frequency distribution in terms of class interval. So these are three types. What those three types are? Individual observations is the first one. So x1, x2, x3 dash 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 xn are n observations. So this is called as individual observations or ungrouped data. Second is we are finding what? We are finding that frequency distribution. Again it has two types, or a group data, it has two types. What do those two types are? One is individual frequency distribution. It is in the form of xi and corresponding fi, means x1, x2, x3, xn are your n observations, and corresponding frequencies are f1, f2, f3 dash 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 fn. So this is called as individual frequency distribution. Next is what? The your classes, your data in terms of class interval. So in terms of class interval, so if I have interval 0 to 10, observations or number of frequency is, let us consider 10, 10 to 20 if it is 20, 20 to 30 if it will be 45. So this is nothing but what? In terms of class interval. This is important whenever you are considering any measure of central tendency or dispersion, because you have to find different formulae based on that, either in you have to write for all the things.